So one of the cool things I get to do in my job is to fabricate stuff like this. This is what we call a spool valve. Why it's called a spool valve, other than the fact that it has a butterfly valve in it, I don't know. But it is an integral part of what we do in our day-to-day production, and we need to have a few more made. So this is going to document the building of this. As you can see, the construction is made up of two 5-inch long pieces of 5-inch diameter Schedule 40 pipe with some flanges, and sandwiched between the flanges is a valve, what we call a butterfly valve, and on each end is an aluminum cam lock fitting. Here you can see the inside where the butterfly valve is. This is obviously the finished product, and so what follows is how I went about fabricating this particular piece of equipment. So I'm going to start out with a piece of flat stock. This is 1/4 inch thick cold rolled steel. You can see that I've cut some circles out of it already. I'm going to cut my flanges out of this. They have to be as round as possible, and so I'm going to cut them with a plasma cutter, and I will show you the process from there. You can see I've marked the center hole for my circle on this particular slide. Something that you learn pretty quickly when working, especially with metal, is the measure once, cut twice theme does not work. So it's important to measure very accurately and very carefully. I've marked this with a sharpening marker, so it's very easy to see, but I'm going to measure the center point of my circle as a starting point, and go from there. Here I've got my circles drawn out for the outside and inside of my ring, or my donut, as you might want to think of it. You can see on the right hand side it looks like we've got a little funny business going on. Just ignore that for right now, and we'll cut that, but we'll try to cut that in a smooth arc. Here you can see where I've drilled a 3/8 inch hole dead center of my two circles, and you'll see what I'm going to do with that in the next slide. So what I've done here, I have a piece of threaded rod and several nuts, and I've bolted the rod securely to my flat stock, and I have measured precisely, and taken another piece of flat stock that's I believe this is 1.5 inch wide, 1/8 inch thick stock, and put a little twist in it, drilled a hole in it to correspond with my rod, and I've bolted that in place at the exact height that I want it. And to this piece, I'm going to mount the cutting head of my plasma cutter, which you can see here. I've just taken a simple worm clamp, clamped my plasma cutter torch head to the flat stock, and you can also see I've got a little guide piece clamped to the tip there to hold it up off the surface of what I'm cutting, the exact amount that they require. This is the tip I'm using is a hold off tip, which they want you to be minimum of 1/8 inch off the surface, and so that helps me just to get the right amount of spacing to get a good cut through the metal. Once everything is lined up, squeeze the trigger and the sparks start to fly. You can see I'm beginning my cut here. Here you can see I've made my outside cut, and because I don't want the metal to fall through, right now I've got it supported on two sawhorses, so I want this to be secure while I cut my inner piece. You can see by the arrows I'd left a little gap in two places just to hold that outside ring to the bigger piece of metal, just to hold it secure until I'm done. And I'll go back and freehand those spots later. I've got my cutting torch lined up on the inner circle and I'm ready to cut. So here we go, cutting the inner circle, and sparks are starting to fly, and I've got a good cut going here. All the sparks and debris are flowing cutting right through the metal, and I've got a good cut going. Alright, so inner circle is successfully cut out. I can remove that along with my jig, and now we'll go on and freehand cut the two spots on the outer ring and let that piece fall right through. Here's the finished product. You can see on the near side it looks like a little bit like a dog has chewed on it a little bit, but I had a little trouble in that spot getting the plasma cutter to cut through cleanly, and it turns out it was just a ground issue. I fixed that, and you can see the rest of the cuts are nice and clean, fairly smooth, and as good as you can get with a plasma cutter. So you can see we've got our two flanges cut, and the pipes that they're going to be affixed to are right there. I made sure that everything lined up well, but I do want to drill the holes before I do the final welding. Here is the aluminum valve body that we're going to sandwich between these two flanges, and you can see the outer body is cast aluminum. The inner butterfly valve, you can see clearly that's made out of brass, and in between them there's a polymer material that makes a good tight seal. So you can see here where there's grooves in the aluminum outer body. Bolts are going to go through those grooves, and so I've marked my flange where I want to drill holes for those bolts to go through. It's pretty important that the bolt holes line up on both flanges, so what I did, you can see by the red arrows show where I tacked these two flanges together so they won't move, and I can use my drill press and drill holes. I've got 6 holes marked, and I'm going to start with a 3/8, and then I'm going to bump it up to a 5/8 drill bit, and we'll just go around and drill these holes and line everything up. This part of the build process can be pretty boring. We've got our two flanges drilled, and I separated them successfully from the tack welds, and so we are ready to start welding the flanges to the pipes. these are the two pieces of pipe. I bought some cold rolled Schedule 40 5-inch diameter pipe from a local metal supplier, and I had another shop actually do the threading. We don't have a pipe threader that goes up to 5-inch, so had another shop do it. They did a great job and cut them to the exact size I needed, and we are ready to weld. So here you can see I welded the inside of the flange to the pipe. I did my best. I've got a Miller MIG welder, and welds came out pretty good for the most part. Got a couple ugly spots, but we want to make sure that those seams are really tight on the inside, that they're really smooth, and we don't want any areas that would allow the product that flows through these to catch. So I'm going to have to grind these smooth, but pretty good welds. My welds on the outside turned out even better. Just wanted to do that for extra strength, and there is product that flows through these pipes in our production situation, so I want to make sure that there's just no chance for any leakage, and strength is certainly an issue. So just laid down a nice bead around the outside. Just another shot of the outside weld. It cleaned up really nice with a wire wheel. It sure looks pretty. And then I took a grinding wheel and just went around the perimeter of the flange and smoothed it all out, and just made sure there was no sharp edges. One half of the pipe and flange assembly welded together, and cleaned up the edges, ground it all nice and smooth. Took the area that I said looked like a dog might have chewed on it, and ground it nice and smooth. Not perfectly round, but that's okay. It still has the strength that we're going to need for our application. Here's the final product bolted together. I screwed on the aluminum end caps that you can see. Used some thread tape just to seal them up, and tighten them down as tight as I could get them, and then sandwich the aluminum valve body between the two pipe flanges, and used 1/2-inch bolts, and threaded them. Used washers and lock washers, and you can see my impact wrench that I used to just tighten them down, and just got them as tight as I could. Another angle of the finished product. Looks pretty impressive. Here's a final look at the finished product, and again, to explain exactly how we use this particular item would require an entirely different video, and it would probably be pretty boring, but suffice to say, this is actually a key component in our day-to-day process as we unload our product into our storage facility. So this is not something that I invented, but it's something that I figured out how to build and how to make ourselves. It saves us a whole lot of money. This is not something that we could go and buy from any manufacturer, and so pretty proud of it. But this is my spool valve that I built. It took me about roughly 2.5 hours of labor, not including the time that it took me to set up all the equipment and then obviously clean up the mess afterwards. But a lot of fun, and this is one of the things that I really enjoy about my job.